Good evening, and hello, and welcome to the video lecture for reflex klystron oscillator. So, in the last class, I had discussed regarding the electronic admittance of a reflex klystron. Let me proceed with some problems related to the reflex klystron oscillator. Okay, the three problems related to reflex klystron oscillator. The first one, that is problems on reflex klystron oscillator. Okay. The first problem, a reflex klystron is operating under the following condition. Under following condition. I will write A, beam voltage is nothing but 6550 volt. Next is beam current is nothing but 10 milliampere. Now I will just neglect this one, A, 10 milliampere. Bunching parameter equal to, which is nothing but J1 of x, 0.52. Okay. Then Rippler voltage, which is nothing but 300 volt. Frequency 9 gigahertz. Distance of Rippler from cavity, distance of Rippler from cavity 2 millimeter. Okay. Then operating distance of Rippler from cavity is at 2 millimeter. Operating at frequency mode is nothing but operating at frequency mode is, that is n equal to 3. If you have to calculate output power from tube, that is PRF is nearly equal to PAC. The first one. Second one, efficiency. Okay, these two things we have to calculate it. So I will give the solution for the same. So PAC is nothing but PRF, which is nothing but VA I naught as per our equation, x J1 of x divided by omega L, VA plus VR root of Q by 2m into V. This I can write it as E, which is equal to C. Okay. This one. So Q is nothing but 1.6 into 10 raised to minus 9 coulomb. Okay. I will write this as E. M is nothing but 9.11 into 10 raised to minus 31 kilogram mass. X is nothing but 2.408. J1 of x is nothing but 0.52. VA is nothing but 650 volt, I naught is nothing but 10 milliampere, F is nothing but 9 gigahertz, VR is nothing but 300 volt, L is nothing but 2 millimeter. These are the things given. So we have PRF is nothing but 650 into 10 into 10 raised to minus 3, that is I naught, into 2.408 x into 0.52 divided by 2 pi f, omega is the 2 pi into 9 into 10 raised to 9 omega L into 2 into 10 raised to minus 3. This is about 650 plus 300. Okay, VA plus VR, root of 1.6 into 10 raised to minus 19 divided by 2 into 9.11 into 10 raised to minus 31 into, what is that one? And VA is 650 into 650. So this is somewhat, you get 0.8119 watts. So just calculate it. Okay. Efficiency eta is given by x J1 of x divided by pi n, which is nothing but 2.408 into 0.52 divided by pi into n plus 3 by 4, that is n is nothing but 3, which is nothing but 2.408 into 0.52 divided by pi into n is how much? 3. 3 plus 3 by 4, which is nothing but 0.1062, that is nothing but 10.628%. Okay. So this is one problem related to, is a direct problem related to what you call as a reflex klystron oscillator. Okay. So I will give the next problem. The second one, sorry, the reflex klystron operates at peak of n equal to 1. The DC power input is 50 milliwatt at the ratio of V1 by V0 0.278. Calculate the efficiency. Okay, calculate the efficiency. Next, related to this point, total output power, related to this problem, total output power, if 15% of power delivered delivered to the beam, delivered total output power, if you have to calculate the total output power, right? Calculate efficiency, calculate the total output power if 50% of power delivered by the beam is dissipated in the cavity 1. In the cavity 1. Okay. Then find the power delivered to the load. Power delivered to the load. These are the things we have to calculate it. I will write the solution for the same. We have PAC is nothing but 50 milliwatt. PRF is equal to eta into PAC. Eta is nothing but PRF by PAC, and eta is nothing but J1 of x, x into J1 of x divided by pi n, which is nothing but x J1 of x divided by pi into n plus 3 by 4, which is nothing but x already we have given. That if they are not given, you have to take it with a 2.4 1.25. Okay, 1.25 divided by pi into 1 plus 3 by 4, which is nothing but 0.2277. That is 22.77%. That is efficiency. Okay, therefore PRF is nothing but 22.77 into PAC, which is nothing but 22.77 or 0.277. I will write with respect to that. .2277. Okay. Which is nothing but 0.2277 into 50 into 10 raised to minus 3 watt, or you can write as 50 milliwatt itself. It is nothing but 11.385 milliwatt. Okay, you have to calculate the total output power. PRF, okay, if 50% if 50% of power delivered by beam is dissipated in the cavity part, so PRF is nothing but 15 minus 15% of 50, which is the 50 minus 15% of 50 will be 7.5, which is nothing but 42.5 milliwatt. So therefore PAC is nothing but PRF divided by eta. PRF is nothing but now 42.5 milliwatt, eta 0.2277, which is nothing but 186.649 milliwatt. Okay, so this is the problems related to another problem, somewhat twisted problem, but if you think it will be simple. Okay, next problem I will give you, you just take down the important points, direct substitution only. I will write the next problem, problem number 3. You solve it. Okay, I will give you the equations and all those things. A reflex klystron is having a beam voltage of 500 of 500 volt, Ripple voltage is 275 volt. The Ripple anode is placed at 1.5 millimeter from cavity. Calculate the following. Calculate the following for 9 GHz frequency. What are that following? A, that is round trip DC transit time, that is T suffix T. B, round trip DC transit angle, that is theta G. Also third one, bunching parameter. Call it X. So I will give you the points. You take the direct solution. So X directly you can write 2.408 because nothing is there in that one. Bunching parameter. TT is nothing but 2 velocity by acceleration, which is the 2 V of Tg divided by acceleration is nothing but E of ml into Va plus Vr. So in order to get V of Tg, you have to go for V0 1 plus V1 beta 1 sorry, divided by 2 Va sin theta G by 2. Okay, beta 1 is nothing but sin theta G by 2 divided by theta G by 2. Theta G is nothing but omega into Tg. Okay, omega is nothing but 2 pi f into Tg. So from this equation you can able to calculate the what you called as all the equations given. Vg is 275, reply anode is Vr is 1.5 millimeter from cavity, that is L is nothing but 1.5 millimeter. F is also given 9 GHz. Okay, you have to calculate the you are having the beam voltage, that is Va is nothing but 500 volt given, Va 500 volt, Ripple voltage Vr, right, Ripple voltage is 275 volt. Ripple space L is nothing but 1.5 millimeter. Frequency is 9 GHz. 9 to 10 raised to 9 GHz. Okay. Then what else? Nothing. You have to calculate the DC. All other things are given. So just do it for this one. Okay. This by using this equation, just calculate the equation for again E equation values of E already you know, M already you know. So nothing is there. You just calculate directly. Okay. Theta G already get 2 pi f into Tg. Calculate Tg. Okay. So these are some of the important points related to this hints related to this, only a hint. Okay, just calculate it, just find the solution. Okay, for this one all the equations I have given here. So here I am stopping the everything related to reflex klystron oscillator. In the next video lecture we can come across the high power oscillator, that is nothing but magneton oscillator. Reflex klystron is nothing but a low power microwave oscillator. So we can go for the high power microwave oscillator, which is otherwise called as magnetron oscillator, in the next video lecture. Okay, thank you.